So this is EFA, which I was talking about. Exploratory factor analysis is a statistical approach for determining the correlation among the variables in a data set. Okay. For example, you have 10 questions, so it will see the correlation among them. This type of analysis provide a factor structure. It means the variable structure, a grouping of questions based on strong correlations. You can determine which questions best measure what you are trying to assess. That way you can shorten your scale from 100 questions to maybe 15. You see, 100 to 15 can be done through the exploratory factor analysis. For example, there is a variable productivity. Okay, productivity. So productivity can be measured through 100 questions by the expert suggestions. Okay, and your own input. But after the exploratory factor analysis, you have found the 15 relevant. So these 15 questions you will be using for your questionnaire. Rest of them will not be using because of exploratory factor analysis. An exploratory factor analysis should always be conducted for new data sets. As I already told you, if you have taken the questions from the researchers, then there is no need. So for new data set, yes, and you should always be conducted. This is important. A critical assumption of the exploratory factor analysis is that it is only appropriate for sets of non-nominal items which theoretically belong to reflective latent factors. Non-nominal means which is nebulous, which has some dimension, which can have dimension as well, and which cannot be measured by single questions. तो non-nominal उसे कहेंगे, and which theoretically belong to reflective latent factors, as I already mentioned in the last lecture, reflective and formative. So the questions must be reflective. Okay, so we will be discussing it further, so don't you worry. So the what we have learned from this slide, the EFA must be done for the new questionnaire, for the new questions measuring the items, for the new questions measuring the variable. Okay, you have to shortlist the questions for measuring the variable. Secondly, it is for the reflective uh, variables. If the variables are if the questions are reflective, then you can use the EFA plus the uh, variable which has to be measured through the questions. So this is has to be applied. And for the new data set, for the not for the adapted, for the new data set uh, being developed by you, you have to apply the. So this is the practically I already told you we will be doing this practically. So let me give the example of construct validity, convergence and discriminant validity. Let me understand you the concept. So this is theoretically, these are the uh, basically theoretically you see, these are the items of self-esteem. Self-esteem construct. Construct means this is the self-esteem variable. Okay, and it has 4 questions. Okay, it has 4 questions. So you see, when it has 4 questions, you need to see that whether these questions are interrelated or not. If they are interrelated, it means it has the convergence reliability. A correlation provides evidence that the items all converge on the same construct. Okay, so correlation means they are related. They are related. So if they are related to each other, it means they are representing a single concept. Let me come again. If all the 4 questions are interrelated, are correlated, it means they are measuring a single concept. With this belief, we check the correlation. Second is, you see the discrimination, that these 2 questions must not be correlated with these 2 questions. If they are correlated, it means they are not defining that. A correlation provide evidence that the items on the two tests discriminate. So the items of locus of control, item means questions of locus of control, that are two questions, must not be correlating the self-esteem questions. Simple. Okay, this is just to make you understand the concept in numbers. So this is the way through the matrix you also see the same thing. So the correlation support both the convergence and discrimination and therefore construct validity. So when you check the convergence and convergent and discrimination, discriminant validity, it means you have checked the construct validity. So through this matrix, you have checked this. Okay, so you see it has the convergence. The correlation is far more than these values. And over here, these values as convergence or the correlation than these values. This is very simple. Achha, this is some, now we are going to apply, and I will be telling you through the different softwares. Through one software, I will be talking about PLS SEM, that is partial least square structural equation modeling we will be using, and SmartPLS. SmartPLS will be the software which we will be using for assessing the construct validity. So these are some important points if you would like to see. The discriminant validity and the composite reliability. Basically, the reliability we are testing, as I already mentioned before, this is the practical testing of the reliability. So we use the construct reliability testing, that is called the composite reliability. So whenever you see the composite reliability, it means it is construct reliability, that is variable reliability. Okay, and we test it through CR, composite reliability. Okay. Next is you see content validity. You check the content validity through the exploratory factor analysis, which we have already discussed. Indicator reliability is degree of explanation of the indicator variance through the construct. This indicator means uh, basically the questions. So the indicator reliability is question reliability. So you see the question reliability, the construct reliability, these two reliability you check it. This indicator reliability is through the factors. Factors loading. Factor loading means variable loading. Loading means the representation of correlation uh, of questions onto the variable. So this is through you do the indicator reliability, composite reliability, discriminant validity. Basically, the average variance extracted should be higher. So through the average variance extracted, you AVE is a new concept for you. So through which you measure the divergence with one measure to another. Degree to which the measurement of different measurement means questions of different variables diverges with one measure. So this you do through AVE. So through SmartPLS software, you get out these values, and I am not discussing the procedure. Procedure is you can learn in 5 minutes, 5 to 10 minutes, or hardly 15 minutes. The software is very easy to use, very easy, and so we are not discussing it. I will be sharing the website if you are interested. So you can visit the website and learn the software in itself. Over here, the values come through the software. So these are the loadings. Basically, uh, loadings means the correlational values, uh, correlational values of all the questions. So p-value, ignore it because it is showing the acceptance, so leave it. Composite reliability is, I have already discussed with you, its value must be 0.6, greater than 0.6, because if it is greater than 0.6, it means your measure are reliable. Average variance extracted must be greater than 0.5. You see all are greater than 0.5. so it is also validated. So it has the thresholds. Threshold means it has the minimum value. Threshold means minimum value. For example, if I say this is my threshold, it means this is my minimum variance. Uske baad the things will be changed. So you see the another two way of measuring the we just discussed about the reliability. Now we are talking about the convergent validity and discriminant validity. Through the AV, uh, we also measured the validity, but now we are this is the another way of checking the correlation of discriminant validity, and this is the HTMT ratio through which we measure the discriminant validity. So it has threshold as well. As you see, these are the square root of AV. So square root of the AV of all the variables must be different from others. You see, or must be greater than, not different, must be greater than. You see 0.841, that is the square root of the AV which we just got from the previous slide. It has to be greater than from all the variables. 0.799, it has to be greater than. This is the way you measure it. So discriminant validity determines whether the constructs in the model are highly correlated among them or not. Okay? So you see the questions are highly correlated to the to in itself, and they are variables. The other variables with other variables, it is not highly correlated. This concept is over here. Simple. The discriminant validity is showing the discrimination. If the HTMT value is below zero point 0.9, discriminant validity has been established between two reflective constructs. It means HTMT ratio below zero point 0.9. So you see AS to AS, the variable AS to variable AS must be 1. The variable LS to variable LS must be 1. But with others, its correlation must be less than 1. So, or less than zero point 0.9. 0.9 is the threshold. So you see the values. So the why you might have been wondering the why these values are not here, because this is the mirror image. The same is happening there. This is the mirror image. One is over here, one is over here, one is over here, one is over here, one is over here. And if you see, if we write the same values, it will be the mirror image. So the way to write this is like this. You can write. You can have the mirror image, but this is the way you present this. Acha, this is the last topic which I already discussed with you in the last presentation, but I would like to mention it. This is basically the concept of the questions. The variables are of two kinds. One is reflective, one is formative. And the formative is the one which is being the variable which is being measured by different questions. You see, if we take the example of live stress is formed with the job loss, with the divorce, with the recent accident. This is called the live stress. So it is formed with a different kind of questions. So they are not correlated. Okay, they are not correlated. For example, job loss and divorce can be correlated, but recent accident won't be. So they are not highly correlated, or you may say they are not highly correlated. So this we were talking about in the EFA. In EFA, you need to see the formative. If the questions are formative, if the variable is formative, you may say if the variable is formative, it means the questions are forming the variable. Then you cannot run its EFA. You cannot explore its factor. Okay, because exploratory factor analysis is for reflective measure only, as I already told you. So you see, this is the basic difference between formative and reflective. So normally in application you find the reflective variable. Very seldomly you find the formative variable. So there is a test in statistical as well which tell you about the uh, variable type. Is it reflective or formative? So no worries. usually you find the reflective variable, usually, but sometimes you find the formative as well. When you find the formative, what you have to do, usually it has the dimensions as well. For example, job loss is here, so job loss will be measuring by 3 questions, and divorce will be measuring by 3 questions. So usually this happens. Could you hold on for a second, because I am getting the call from the main. Assalamu alaikum. Walaikum salam. Yes, I'm done. The call was over. Acha, so I hope you have understood. The example are given over here. This is the formative one, in which health is being formed by the sleeping, enough sleeping, they exercise regularly, and a balanced diet. So diet, sleeping, and exercise both are forming. All of the three are forming the health. Over here, you see that diet is being reflected by 3 questions. So this is usually we come across. So you need to focus on this. It is just for the theoretical concept, which inshallah will be helpful for you in the days to come. So this is another example of one variable could be formative and reflective as well. सही है. So you can see, you need to see that which you need to prefer. You can prefer as per your requirement. So usually we go for the reflective measure usually. Uh, so this is the detail of the same nature of relationship theoretically. What is the nature of relationship theoretically? From indicators, from questions to construct, indicators define the construct. Is the questions define the variable? From if you see the reflective, from construct to indicator, it is about the arrow. Indicators, questions manifest the construct. So questions basically represent the construct, all the questions. Okay, so it represents, it reflects the variable, and it defines the variable, or it forms the variable. Impact of changes, you could see indicators cause, yeah, pad lega. So there's they are highly correlated, as I already told you. They are highly correlated since it is the reflective measure. So they are highly correlated. So they are highly correlated, and because of their highly correlation, you measure things accordingly. So for all your testing, usually you take this one, reflective measure, and over here you see low correlation and no correlation. So that's it. We are done with the half part of the chapter 4. Sorry, rest of the part of short chapter 12. So just last topic is remaining, which I will be sharing with you through the video lecture of mine. So you have to get this. Thank you very. I want